so welcome to this chemistry flipped classroom video. In this video, we're going to continue to go over how to put together the calculation for figuring out how much heat is required to raise the temperature of a substance. Take a minute to pause to write down our objective now. All right, so when we're looking at this, the first thing we want to do is figure out what's given to us. We then want to figure out what our equation will be. And finally, we'll solve. These are the three steps that we're going to do. So I'm going to write out 3 columns for our 3 steps. On your paper, you should follow along by drawing these columns. So in the first column, we have our givens. These are things that the problem told us. In the middle column, we have what's going to be our equation. And in the final column, we have solving. So when I read this question, there's a couple things that pop out at me. How much energy is required to raise substance X from 25 to 75 degrees Celsius? So we know that we're dealing with substance X. All right? That's the substance that I'm dealing with. So one thing I know is that I have substance X. The next thing that I know is my change in temperature. My change in temperature is going from 25 to 75 degrees Celsius. All right? So I know that this is going to be my change in temperature. Another thing that I can then get from this is that the total change is 50 degrees Celsius. So my delta T is going to be this 50 degrees Celsius. Now, an additional thing that's given to us in this problem is my specific heat. This number right here. Now, this number is important to me because that's going to be the C part of my equation. So in this case, I'm just going to write C equals 5.2. And this has that funky unit that's joules per grams times your degrees Celsius. All right? It's important that you keep this unit attached because that's going to be part of our entire equation. All right? The last thing that this question didn't tell us, this question wasn't worded very well, we need to know how many grams we have. So let's just assume that our grams are going to be equal to 10. All right, so that's a given. We have our mass is equal to 10 grams. All right, their mass, this would be mass. So mass is 10 grams. So now we need to figure out our equation. When I figure out the equation, I'm going to ask myself 2 questions. My first question is this phase change? My second question is this raising temperature? All right? If I'm raising temperature, then I have a change in temperature. That means I'm going to want to use the equation that has the delta T. Remember, we're going MC delta T. So the equation we're going to use in this case, because it's a change in temperature, is going to be MC delta T. Q equals M times C times delta T. Now sometimes it's helpful in the equation column just to fill out again what each of these 3 things will be. Your 3 variables in this case, your mass is 10 grams, your C is 5.2 joules per gram times degrees Celsius, and your delta T is going to be 50 degrees Celsius. Notice that we have all of these things in the same units. Our grams go with our grams, and our degrees Celsius go with our degrees Celsius. If there's a time those aren't in the same units, then we're going to have to balance them out and do some conversions to get them to be the same units. All right? So the last step is simply solving. All we're doing is plugging in our givens to our equation to then solve. All right? So I'll write that out for you. All right, so this is all written out. So all you have to do for homework is plug this into your calculator and send me the solution. All right, this is that extra credit part. Send me what Q is equal to in this case. You can send that right to my email. All right? Hopefully this has helped you figure out a little bit more how we set up the Q equals MC times delta T and when we use that equation. From now on in class, we're going to use this 3-column method to solve this type of problem. See you in class tomorrow.